Hello friend, welcome back to my channel. So today we will discuss here about the next topic, which is a very important topic of ray optics. The topic name is dispersion through a prism and prism formula, or you can say that the refractive index of a prism. So before that, you should understand about what is the meaning of refractive index and what is the dispersion of light. About the refractive index, I have explained in my previous video what is the definition of refractive index and what is the relation between the refractive index and the speed of light. And along with this, I will give you one more relation, which is the relation between the refractive index and the wavelength of light. So see here, as we know that refractive index, when we talk, it is two types. One is relative refractive index and other is absolute refractive index. So here when we talk about the refractive index, which is relative, denoted by N21, means when the light goes from one medium to another medium. So the refractive index of second medium with respect to first medium is called its relative refractive index, means refractive index of second medium in which light is going with respect to that medium from which light is coming, means refractive index of second medium with respect to first denoted by n2 by n1, and you know that the formula it is equals to v1 by v2. Now here, as we know that by the laws of refraction, the refraction law is that when the light goes from one medium to another medium, its frequency and phase does not change, but its wavelength or color, or you can say speed, changes. Means when the light goes from one medium to another medium, means in case of refraction, frequency and phase remain same, but wavelength and speed changes. So for this condition, if I will give you the example, as we know that light has transversal in nature, means as we know that light is an electromagnetic wave by Maxwell theory. So as we know that it is an electromagnetic wave, so in which the electric vector and magnetic vector both are perpendicular to each other, or you can say that when the light ray goes through it, electric vector and magnetic vector perpendicular to each other, and after that, if I suppose draw the diagram of light ray in this way, transversal form, so here your east is there and rough part is below, as you know that. So the distance between two consecutive or successive crease is called lambda. Point clear? And the time taken to complete one revolution like this from this point A to this point C after going the point B, means ABC is your one of revolution in this waveform. So here time taken for one revolution, as we know that distance between two successive creased or troughs is equals to lambda, and time taken for one revolution, as we know that time taken for one revolution it is denoted by capital T. After that, when we talk about the speed of light, as we know that in vacuum the speed of light is c, so here we can write speed of light is equals to c. So now the formula is, if we use the formula, distance equals to speed into time. So distance is lambda, speed is c in vacuum, and time is a time period for this wave. So here, as we know that one more relation, since time period is equals to 1 of frequency, 1 by frequency means reciprocal of frequency, and frequency, if you want to see, you want to show the frequency by mu symbol. So here lambda is equals to c by mu. So it is equals to c is equals to mu lambda. So this is one important relation which is related between the speed of light in vacuum the wavelength of light, or you can say the color. After this relation, we can see here if we think about any medium, for any medium in place of vacuum, for any medium in place of vacuum, if I will apply this formula, suppose here I have two medium, medium 1, medium 2, and these two are other than vacuum. Suppose light is going like that. This is the actual path of light. 1, 2, and here refractive index N2, N1, here speed of light V1, V2, and listen carefully, when the speed of light V1 is here, then it's supposed to be lambda 1 is the wavelength of light here. As we know that diffraction case, wavelength is changeable. So here in this medium, lambda 2 is the other wavelength, or you can say that lambda 2 is the wavelength of light in second medium by law of diffraction. So by this formula, we can write for medium, for any medium, we can write here for this V1, V1 is equals to mu, frequency remains same. Here also mu1 is the frequency which is equals to mu, and mu2 which is also equals to mu. So frequency remains same in both of the condition. So here V1 is equals to mu lambda 1 and V2 is equals to mu lambda 2. You can write this relation with the help of this. So you can substitute the value of V1, which is mu lambda 1, and this is mu lambda 2, mu to mu cancel, lambda 1 by lambda 2. So by this relation, we can say that N21 is equals to V1 upon V2 is equals to lambda 1 upon lambda 2. Now, if we think about here the refractive index, one more relation you can see from this, you can write this part also along with this. So this one. So by these two, we can see here N2 by N1 is equals to lambda 1 by lambda 2. It implies us refractive index is reciprocal of, you can see here, refractive index is reciprocal of lambda. If suppose in any medium the wavelength of light means the light ray which is entering in that medium have greater wavelength, so that time if the wavelength is greater, the bending of light means refraction, the bending of light in that medium is slower, lower, means less bending, greater wavelength, less bending, and smaller wavelength, larger bending. This is the relation, meaning n inversely proportional to lambda. After that, with the help of this relation, we can discuss dispersion of light. What is the dispersion of light by prism? After that, we will talk about the prism. Point here. So for that, pause the video and note down. Next heading is prism formula. And before that, we will talk about dispersion of light, okay, by prism. Dispersion of light means when the light goes from, when the white light goes from one surface, or you can say one face of the prism here. Suppose P, Q, R is our prism. When the white light means it has 7 colors. Means white light, when we talk about from source, the light which is coming from source is here white light, which contain 7 colors which are in visual pattern, contain 7 colors known as pure, and these colors are in visible range or visible colors, and the wavelength order of these colors 4000 angstrom to 7800 angstrom. This is the range, near about the range of the visible light, which contains in white light. And after red, we have infrared patterns, and below violet, we have ultraviolet patterns or ultraviolet wavelength light ray and infrared wavelength light rays, which are not visible by eyes, human eyes, naked eyes. So here we are talking about only the seven colors which is in front of you: violet, indigo, blue, green, yellow, orange, and red. So when the white light enter, here I am drawing the diagram of dispersion of light. After that, we will talk about the prism formula for the monochromatic light. So here, when the white light enter in any phase of the prism, it becomes dispersed. Dispersed means splitting of white light into seven colors due to the reflective index of medium and also the wavelength of color, which is different from each other. One, two, supposed to be this. So these are seven lines or seven figures. First, second, this is the diagram. You can draw the diagram by your book with the help of pencil and color. So see, violet color has less wavelength, so it bends more because as we know that N is inversely proportional to lambda. The color light of color which has smaller wavelength, it bends more when it goes from prism or any surface, refracting surface, and on the other hand, remaining will be according to the order of their wavelength. And red has greater wavelength. Out of these seven, red has greatest, so it bends less as compared to other six color. And if we extend these line, which is a incident line, if we extend the incident ray in forward direction, and if we want to extend the ray in backward direction, which is a emergent ray, suppose this is for red color, and here if we extend according to this straight backward, it is little bit pink, but you will draw proper. These two angles we have, and these two angles are known as the angle which is between the ray, incident ray extended forward direction and emergent ray extended backward direction. This angle is called angle of deviation. Here, this angle for red color, so it is angle of deviation for red color, and this for violet color, so it is for violet color. Point clear, student? And this is the ray for red and other colors, which is called emergent rays. Point clear? So this is a incident ray. Now the dispersion. So what is the meaning of dispersion? So dispersion of light. Dispersion of light. It is the phenomenon of white light into seven colors when it passes through the prism. Point clear? When it passes through the prism, known as dispersion of light through a prism. Dispersion can be possible with the help of refracting surface, means lenses also, due to which the aberration, chromatic aberration is there also. So here, when we are talking about dispersion of light, so we are talking only for, in this case, which is a prism. So this is the definition of prism, and now after that we will talk about the prism formula, in which I will discuss what is the meaning of angle of deviation. So again, I have drawn the prism diagram for monochromatic light. This is our monochromatic ray or light. Monochromatic ray means that which have only a single color incident. And when this light passes through the prism, it becomes like that. This light will be parallel to the base of the prism if we are talking about the minimum angle of deviation. So initially I have drawn this because I will take this condition to write the relation of refractive index of prism or prism formula, which is sine A plus del m by 2 over sine A by 2. Point clear? So let's see how we will prove it. So this is a emergent ray. This is the original direction of incident, and this is the backward direction of reflected. And this is the angle of deviation for this monochromatic light ray or monochromatic incident ray. Point clear? So as we know that here, when we are talking about the prism, so prism angle supposed to be denoted by A, and when we are talking about the refraction through a prism, so that time this part, as we know that here, I forget the initially, यहाँ पे हम लोग नॉर्मल रखेंगे, जो मैंने इनिशियली नॉर्मल नहीं ड्रॉ किया वो रेंडमली मैंने आपके पास डायग्राम ड्रॉ कर दिया. You can draw normal. This is your normal on the surface PR and PQ. Point clear? It makes 90 degree. This angle is 90 degree. This angle is 90 degree. Listen carefully. These two normals intersect each other at a point. Supposed to be that point is a O point, and this is normal N1 or N2. This is normal ON1 and ON2, and remaining all we have here. Now, when we talk about this angle, this is a monochromatic ray. This angle is an angle of incident, and the angle which makes by the refracted ray with this normal ON1 is called a angle of reflection. Similarly, here R2, and here this is the emergent angle. If you want to see, you can write E. Otherwise, it is I2, because this ray diagram is a symmetric diagram for this prism. Why? Because in place of this, if suppose the light enters from this corner, means from that side, then it will follow the same path. In case of minimum angle of deviation, I will put the condition of I1 is equals to I2, then R1 is equals to R2 for minimum angle of deviation. So here we are talking about the case for minimum angle of deviation to observe this relation n is equal to that part. So for that condition, the incident ray and emergent ray are symmetric in nature. So that's why I have drawn this diagram like that, so that I have written here I2, R2, R1, I1 and all. Now we will talk about the relation. See, if you will use here the relation in this triangle, if you will see in this triangle, supposed to be this is O dash. In triangle O dash, and this is supposed to be L and M. O dash L M. Now you can see the diagram. From diagram, here we are calculating prism formula. From diagram, in triangle O dash L M, when you will see this angle which is del known as angle of deviation. I will write the definition, angle of deviation. So this is the exterior angle for the triangle O dash L M. So I can write by exterior angle property, by exterior angle property. So we can write del is equals to the sum of that angle and that angle. Here the whole angle is I1 and this part is R1. You can use, so I1 minus R1 is that part and I2 minus R2 is that part. You can see the diagram from your book. If you have any doubt and confusion in this diagram, if the diagram is complicated, you can see it in your book. So here, by following the geometrical properties here in this triangle O dash and M, I will see this del is equal to sum of interior opposite two angles, which is del is equals to I1 minus R1 plus I2 minus R2, and if I will arrange your I1 plus I2 minus R1 plus R2, this is the value of del. For minimum angle of deviation, minimum angle of deviation means deviation will be greater if the wavelength of light is smaller, and the deviation will be smaller if the wavelength of light is greater, as n inversely proportional to lambda. For minimum angle of deviation, as I told you, I will put the condition I1 is equals to I2 is equals to supposed to be I, and R1 is equals to R2 is equals to R. I will put these condition. So del is equals to, and also del goes to del n. It is replaced by del n simple minimum angle of deviation. So it will be 2I minus 2R. Point clear? Note down this equation. Now come to this triangle. First, come to this triangle LOM. In triangle LOM, see this. Yes, this part is visible. So in triangle, which I have said LOM, you can use the triangle property, angle sum property, R1 plus R2 plus angle LOM. LOM is equals to 180 degree by angle sum property. So here angle LOM will be 180 minus R1 plus R2. This is your equation number 2, and this one is equation number 1. And after that, now you can see the quadrilateral PLOM. To solve this, now let's see in quadrilateral which is PLOM. In this way, we will see here angle PLO and PMO is 90 degree. So here I am writing angle P plus angle PLO plus angle MOL or LOM. Here LOM written. So LOM and this one PLO and PMO. PLO I am written. So PMO is equals to 360. We know that. And these two angles are 90 degree. You can see normal is perpendicular to the surface or to the face PQ. So here angle P, which is equal to our prism angle, and after that the remaining part, the sum of PLO and PMO, it is equals to 90 degree plus LOM plus again 90 degree is equal to 360 degree. 90 and 90, 180, 180 will go that side, and we will get here angle A, angle LOM is equals to 180 degree. Now you can substitute the value, or you can compare this relation with this relation, or you can substitute according to your choice. You can do it. You can do. The simple way is that if you will take this is your second condition, then this you can substitute directly here in place of 180. So I am erasing this part. This is the extra value. So from second and third, sorry, second and third, you can see here this is also equals to 180. This is also 180. So I will compare the both of the relation LOM R1 plus R2 plus angle. In place of 180, I will write angle LOM. Cancel out. A is equals to R1 plus R2. So this is your equation number 4. Now you can see, as I have written here, R1 and R2 both are equal, because here we are taking the case of minimum angle of deviation. So A is equals to R1 plus R2 means R plus R2R. So in place of 2R, you can substitute the value directly here, or you can write R is equals to A by 2. This part is important for you. Let us consider this equation is a fifth equation. Now after that you can substitute the value of 2R from equation number 5 to equation number 1. Point clear? So see what comes. Therefore del m is equals to, therefore from equation 1 del m is equals to 2I minus 2R. 2R means A. Point clear? This is the value of del m, and when we solve this part, see here del m plus A, when it will go that side, equals to 2I, and after that I is equals to del m plus A by 2. This is your equation number 6. So here we have the value of angle of incident, and after that we can use the value of refractive index. Therefore refractive index of prism n is equals to sin I over sin R. N is equals to sin. In place of I will put the all value del m plus A by 2 and sin R. R means A by 2. So this is the formula of your refractive index of the prism, or this formula is also known as prism point. Point clear? So this is the point, or this is the derivation and points how we will get the refractive index of prism. And after that, when we talk about the definition of minimum angle of deviation. So see the definition of minimum angle of deviation. Just wait and see here. At last, the definition of minimum angle of deviation, or you can say angle of deviation first. Minimum angle of deviation is only for one of the conditions when I1 is equals to I2 and R1 is equal to R2. That angle of deviation is converted into minimum angle of deviation. Otherwise, normal definition of angle of deviation then it is it is the angle between the rays, the extended rays. It is the angle between the incident ray extended in forward direction like this, in forward direction, comma, emergent ray in backward direction, and emergent ray in backward direction. These two rays, extended forward direction and emergent ray in backward direction, intersect each other at a point. That point we receive an angle there which is called an angle of deviation. It is denoted by del. For minimum angle of deviation, it is already clear I1 is equals to I2 and R1 is equals to R2. That time the angle of deviation del is goes to del L. It is not written here. When I1 is equals to I2 for minimum angle of deviation, R1 is equals to R2. That time the value of angle of deviation del is equals to del L. Point clear? Now after that we talk about the next one relation. See here, means it is a relation between the angle of deviation and refractive index. As we know that from first equation, from where I have written del is equals to I1 plus I2 minus R1 plus R2. So when we talk about here Snell's law, mu is equals to sine I by sine R. You can see the diagram once again as I have drawn here. These are the normals and this is the angle of deviation. See here, I1 is here, R1 is here, R2 and I2. Now when the light goes from exterior medium, from vacuum to any medium air, so that time when we talk about PQ, refractive index of that is P. When we talk about as we know that the whole refractive index is same for the prism, but when we talk about the refraction of light when it reflects from the face PQ, that time I1 is the angle which is the incident angle and R1 is the refracted angle. So when we use the formula of refractive index of prism for this condition, so I will write mu is equal to sine I1 and sine R1 for face PE. So if these angles are very small, means I1 and R1 angles are very small. If angles are very small, so that time sine I is converted into I and sine R is converted into R. Here I1, here I R. So from this relation I will substitute the value of I1 which is equals to QR. Similarly, we can write similarly for phase PR, mu is equals to sin I2, as I told you, sin I2. As I told you, it is symmetrical ray presentation, means these ray, incident ray and emergent ray are symmetric to each other, symmetrical. So that's why I have written this formula. And if again the angles are very small, so I can write mu is equals to I2 over R2. And after that, you can see I2 is equals to mu R2. Point here. So this is the value of, you can write here star equation, double star, or this is a star equation. So now we can substitute the value of I1 and I2 from these two equations to here, to obtain the relation between the angle of deviation and refractive index of prism, which is very important and useful formula for you. Now see here, student, from equation supposed to be, this is our equation number 1 in my previous pages. From equation 1, that is equals to, in place of I1 I can write mu R1, in place of I2 I can write mu R2, and here R1 plus R2, taking mu as common, R1 plus R2 minus R1 plus R2, again you can take common R1. If you will take common R1 R2, R1 plus R2, you can write this equation like this. This is a common part. And we know that, student, R1 plus R2 is equals to your A from the previous equations. This R1 and R2 is equal to phase angle. So you can substitute the value of R1 plus R2 which is equals to A. So this one. This is also one of the condition which is related between the minimum angle of deviation or angle of deviation and refractive index of prism. Point clear?